Okay, good morning. My name is Gautam Verma. I work as an assistant professor in EEE department, ACE Engineering College. Me along with Moni madam, we will be taking your class, lab class on EM1 or electrical machines 1. So today I will give an explanation or to experiment with the name of load test on DC shunt generator. Okay. Now first what is going to be my approach is that I will explain why, what is the meaning of this load test on the DC shunt generator, what is the need to do this experiment, then to do this experiment what are the things we need like apparatus, then we will explain what is the nameplate detail, after then I will explain how to use this apparatus to create this circuit diagram, how this circuit is working, and once we understand how the circuit is working, how to take the tabulation, once you take the tabulation, again how to draw this graph, after then we will go to the module, and in that module we will practically do it. Okay, so let us start with the name of the experiment is load test on DC shunt generator. Now first thing, why do you want to do this experiment? Okay, what is the information that we are going to get? A DC generator has 4 characteristics. Out of that, one is known as load characteristic of DC shunt generator. Whenever we talk about characteristics of anything, any equipment, any person, anything, it gives some information about that equipment. In this case, when I perform a load test or any particular characteristics on a DC shunt generator, I am going to understand some behavior of the DC generator. So I have to understand how the DC generator acts, some information about DC generator. That is why we are doing this experiment, load test on DC shunt generator. Now what kind of information we are going to get? Now to understand what kind of information we are going to get by performing this experiment, we have to go back to the basics of a DC generator. The purpose of a DC generator is to generate electrical power at constant voltage. Please remember this one, at constant voltage. That thing is very important. The purpose of a DC generator or electrical generator is to supply electrical power at constant voltage. Now when I am telling DC generator is supplying power, to what it is supplying power? Answer is to load. Now next question, how many loads? 1 load, 2 load, 1000 load, 3000 load, 20 load, 30 load, how many loads? Now that is where our experiment is related to. Suppose if I increase the number of load to which the generator is supplying power, what happens to its terminal voltage? Suppose let me say that I have a generator, it is without any load, it is generating a voltage of 220 volt. Now I will apply one load, I will see how much voltage is now. Next I will apply another load, then I will see how much voltage is there. I will keep on applying load, and I will see that how the voltage at the terminal of the generator is varying. Ideally it is expected that it does not matter how many number of loads has been connected to the generator, the amount of the magnitude or the voltage at the terminal of the generator should remain same. Or in other words, it does not matter how many loads I have connected across the DC shunt generator, the voltage generated by the DC shunt generator should not change. That is what I ideally expect, but practically it is not like that. Practically what happens is that as you keep on increasing the number of loads connected to the generator, the terminal voltage or the voltage generated by the shunt generator is going to keep on decreasing. That is what we are going to understand. Okay, so that is our objective. We are going to verify what will happen if I keep on increasing the load, how the voltage is changing, by how much it is changing. That is our objective. I hope you understand that. Next, what are the things we need to do this experiment? So that is your apparatus required. Here we have ammeter. We need ammeter, 2 ammeters I need. One is 0 to 2 ampere, another is 0 to 20 ampere. It is shown here. It is 0 to 2 ampere, 0 to 20 ampere. Both are MC type. The meaning of MC is moving coil. What is moving coil? You will learn when in 3rd year. Okay. Now we have a voltmeter. This voltmeter is 0 to 300 volt, MC type. Here, that one. Then we have a rheostat. 370 ohm, 1.7 ampere. The meaning of 370 is that this rheostat can be changed from 0 ohm to 370 ohm, and the maximum current that should pass through this rheostat is 1.7. You should make sure that the current through this resistance, this rheostat should not be more than 1.7 ampere. Now this tachometer, we use tachometer, it is a digital tachometer, we use it to measure the speed of the motor, and its rating is 0 to 3000 rpm. It means it can measure maximum 3000 rpm. Now nameplate details. In nameplate details we are going to see, suppose whenever we are going to purchase a generator or motor, some data will be given regarding that voltage and that generator and motor, and the data that is given on a plate and it will be fixed on the motor, that thing is known as nameplate detail. When I go to the module of this experiment, I will show you what are the nameplate details. Here for generator and motor, both cases, both these two machines, we have same rating, and here voltage is 220 volt, current is 15.9, output is 3.5 kilowatt, and speed is 1500 rpm. This is the rating of my DC generator as well as motor. Both are having same type of nameplate detail. Okay. Next, once you know this one, next we will see this circuit. How you are doing how it is connected is like this one. Why it is connected like this one. Okay. First thing, what is the name of the experiment? Load test on a DC shunt generator. This is my generator. This is my motor. Now the question here is that I want to do something with the generator, then what a motor is doing here. Okay. To answer that question, you should know that how a generator works. I have a generator. It needs two things to work. One is flux, another is speed. One is mechanical input, another is electrical. In DC shunt generator, it is shunt, that is why we do not have to give any external input, but we have to give a mechanical input. A DC generator will start to generate if and only if you are going to give a mechanical input. We know that generator converts mechanical energy to electrical energy. Here that mechanical energy is given in the form of speed, and that speed is given by this motor. So I have a generator, I have a motor. This thing is known as mechanical coupled. The meaning of mechanical coupled is that I have a generator, I have a motor, they are mechanical coupled. Suppose motor is moving means generator is moving, like this one. Both are moving. So if you want to rotate this generator, you have to rotate this one. That is why we are using motor. The purpose of this motor is to provide mechanical energy in the form of speed to the generator. That is the purpose of motor. Then we'll go back to here. Let us focus on this one, what is going on here. Then I'll tell you what is going on there. Now here, let me say that I am getting sufficient amount of speed. Okay. Now what is the rating of this one? The rating of this one is 220 volt. Okay. How much volt speed? 1500 rpm. This means that if this generator of the rotor of the generator is rotating at 1500 rpm, then I can see a voltage of 220 volt. How to know how much voltage? Use this one. Use this voltmeter. Why the rating is 300? Because maximum voltage is 220. That is why I am using 300. Suppose your maximum voltage there is 350. Then you have to use some different voltmeter. Rating of the voltmeter. Now, so when I give 1500 rpm, I am getting this voltage. Okay. Now what is the use of this one? What is the use of this ammeter? What is the use of this rheostat? And what is this thing? I know that, let me say that. Okay, suppose at the starting, this motor is not going to give 1500 rpm directly. Slowly the speed will increase. Okay, slowly the speed will increase up to 1500 rpm. What I will do is that at the starting of the experiment, I am going to keep this rheostat at maximum position. If I keep rheostat at maximum position, this means that minimum current will flow, and that current that is flowing in this field winding will be shown by this ammeter. Again, what is the rating of this ammeter? 0 to 2 ampere. It is going to very less current. Okay. Now, so less current is flowing. Now again, now see, generator is there. The purpose of generator to create voltage or take mechanical input and produce electrical output. What is the mechanical input? Your speed. Now next, only mechanical input is not sufficient to produce voltage. We need something else. What is that something else? Flux. How that flux is coming? The flux is coming because of field current. Now what is the field current? The current that is flowing in the field. So there is a field in the generator. This is my field. The terminals are Z and ZZ. This is the field of the generator. If I pass a current here, then and only then. So we need two things. We need speed and a current here. Only under that condition I will get a voltage. If you have a speed but there is no current, no speed, no voltage. If there is current but there is no speed, again there is no voltage. So we need two things. There should be speed and there should be this current. Now suppose I am keeping this rheostat at maximum position. Why I am keeping it at maximum position is that if I keep at maximum position, current is less. If current is less, voltage is less. Now what is my purpose? I will increase slowly. I will increase the voltage to its rated voltage. So what I will do is I will slowly increase this one, slowly decrease the resistance. If I keep on decreasing the resistance, the current will keep on increasing. If current increases, the flux increases. As flux increases, the voltage increases. As the voltage increases, you will see here, this voltmeter will show that the voltage is continuously increasing. Okay. Once you get this voltage, rated voltage 220 volt, then what I will do that I will switch on one load. Then I'll note down the voltage, current. Then I'll switch on another load. Then I'll again note down. I'll keep on switching loads until I get my rated current. I'll go up to 15 ampere. That is my rated current. So this part is over. What you are going to do here? Now here. Now as I told you, once I switch on this one, it does not mean that this motor will suddenly go to 1500 rpm. We have to increase the speed of the motor slowly. How to do that? Means to do that we have this arrangement. This arrangement is for the purpose that we have to increase the speed of the motor gradually to its rated speed. How to do that? Okay, now see. I have now in this circuit. So this circuit is for motor. This circuit is for generator. First you have to operate here and bring this motor to 1500 rpm. Then you have to operate that one. So I have explained that one. Now next we will go to this one. Here what we are doing is that we are giving a supply. We have a DPST switch. The meaning of DPST is double pole single throw. What is that one? I'll tell you when you go to the module. Okay. Then we have fuse. This fuse is to control, or in case suppose because of some mistake in the circuit or doing experiment, something happens and the current more than rated current is going, then this fuse will blow off and it will save the total equipment, because these equipments are very costly. Okay. Next we have this 3-point stator. In this 3-point stator I have L, Z and A. L is connected to the line. This Z is connected to the field winding of the motor. Just like generator, I also have a field winding of the motor. Z, I have a rheostat. In this case, the rheostat is at minimum position. And this is my armature. Armature A is connected to here. A dash is connected to this negative supply. Okay. Now here what I am doing is that this rheostat is at minimum position. Now, why I am using this rheostat to control the current that is flowing in this particle, in this field winding, or to control the amount of flux that is being generated. Now, you may ask why we are keeping it at minimum position. Why we are keeping this rheostat at minimum position? Is that suppose let us, if this is at minimum position, means resistance is very small. This means that resistance is small. You see, if this point is at minimum position, my resistance is small. If resistance is small, then your current is small. If your current is small, then flux is small. If flux is small, then there is a formula, I think you will learn later. What is that? N is proportional to EB by phi, or N is proportional to 1 by phi. The meaning of this expression is that if flux is maximum, speed is minimum. If flux is minimum, speed is maximum. At the starting, we do not want the motor to suddenly go to 1500 rpm. We want slowly. I want the motor to slowly increase it to 1500 rpm. To slowly increase, what is speed is small. Speed is small means flux is high. Flux is high means current is high. Current is high. Current is high means resistance should be less. Okay. Okay, sir. Okay. Okay. Okay, I think I made a mistake here. Okay, sorry. If resistance is small, current is high. If current is high, flux is high. Flux is high, speed is less. Speed is less, starting. Slowly will increase it to rated speed. Okay. Now, so this is what we have done. Now, how to start means first switch on this supply, then switch on this stator, then you start the experiment as I have told you. Then you keep on this one, keep moving in this direction. Means keep increasing the value of resistance. As you keep increasing the value of resistance, your current will keep on decreasing. As current will keep on decreasing, your flux will keep on decreasing. As flux keeps on decreasing, your speed will keep on increasing, and keep increasing this one until you get a rated speed of 1500 rpm. How to know that I have got 1500 rpm? By using this digital tachometer. Okay, while doing the experiment, we will understand that thing. Next, once you get all this data, you are going to fill up this table. What is this table? We have a IL is my load current at the starting. See here. At the starting, this switch is off, so load current is 0. Next, I'll keep on loading one by one. Then, as I keep on increasing the number of loads that I am connecting, the IL will keep on increasing. So, you take the value of IL, then IF. This will give you IF. Then IA. IA is, I hope you know, IL plus IF. You get this one. Then VT. This one will give you VT. Then E. How to find E? The formula for E equals to V plus VT plus of IA RA. To do RA, again we will do an experiment to find out RA. Okay, we'll see that one. Okay. Next, so this is your tabulation. Once you do the table, then you have to draw this graph. This graph is IL versus E and IL versus V. Now see, there are two graphs. One graph is what you call IL versus VT. This is your load characteristics. This is what we are doing. Another we are going to draw it IA, another IL versus V. That is an internal characteristics. My focus is this one. IL versus VT means load current versus terminal voltage. That is my load characteristics. That is what we are doing. Now, once this is over, then I talk about this precaution. This thing is very important, particularly for students. I have observed this people do not follow this one. So, what are the precautions that we are going to take in this lab is that it is not a simulation, it is not a computer lab. Okay, that you make mistake and nothing will happen. Here, if you make a mistake, something will blow up. So something you will see smoke, you will see fire, something you will see spark. So we have to avoid that. So from the student side, what I expect is that first of all, please wear shoes. Everyone, wear your apron, and boys, please tuck in your shirts. Try to come in formal. Always come in formal. Tuck in your shirts. And girls, please, if you are wearing dupatta, wear it behind backside. And if you are, please do not let your hair loose. Please do something with your hair. Means what you call it? There is hair band. Use a hair band. Make sure that you are not let your hair loose in this lab, particularly in this lab. Please take care. It's a very dangerous lab. Any mistake, something will blow up. Okay. Now this is what we think about this experiment. Next we'll go to the panel and we'll do the experiment. Okay. That's all. Thank you. Thank you.